Imagine driving through the depths of the ocean, millions of liters of water above your head, yet you are safe inside a tunnel that stretches for miles beneath the seabed. How is this even possible? How did engineers create a structure that can withstand the crushing pressure of the ocean? How did workers reach the middle of the sea to build its foundations? And most importantly, how much did it all cost? The idea of building tunnels underwater is not new. The first underwater tunnel concept dates back to the 1800s in England, when engineer Mark Brunel designed the Thames Tunnel in London. This was the first tunnel built under a navigable river, completed in 1843. It was a breakthrough at that time, but the idea of tunnels under oceans was still far from reality. Fast forward to the 20th and 21st centuries, and the world has witnessed the construction of some of the most ambitious underwater tunnels ever built. The Seikan Tunnel in Japan, the Channel Tunnel between the UK and France, and the Kong-Zhuhai-Macau tunnel system are all marvels of human engineering, proving that no challenge is too big for mankind. But how do you even begin to build a tunnel under the ocean? The construction of an underwater tunnel is one of the most difficult engineering challenges in the world. There are two primary methods used. One, the tunnel boring method, also known as the drill and dig method. In this method, huge tunnel boring machines, or TBMs, are used to dig through the seabed. These massive machines work like giant drills, cutting through rock, clay or sand and creating a passage for the tunnel. This method is used when the seabed is stable enough to be drilled without collapsing. Two, the immersed tube method, which involves pre-built tunnel sections. This method is used when a tunnel needs to be built in deep water. Large prefabricated tunnel sections are built on land, then floated out to sea. Once in position, they are sunk to the ocean floor and carefully connected. Engineers seal the joints tightly to prevent water from leaking in. This method was used for the Channel Tunnel and the Kong-Zhuhai-Macau tunnel. But just digging a hole or placing tunnel sections isn't enough. The tunnels need to be reinforced with steel, concrete and waterproof coatings to prevent them from collapsing under the immense pressure of the ocean above. Building a tunnel on land is already difficult, but doing it under the ocean presents extreme challenges. First, there's water pressure. The deeper you go, the higher the pressure. Some tunnels, like Japan's Seikan tunnel, are more than 240 meters below sea level. At this depth, the pressure is crushing, and engineers must build tunnels with extremely strong walls to withstand the force. Next, we have ocean currents and tides. The movement of water makes construction difficult. If a tunnel section is being placed under the ocean, strong currents can shift it, making it hard to align properly. Engineers must carefully plan construction windows when the tides are at their lowest. Then there are earthquakes and natural disasters. Some underwater tunnels are built in earthquake-prone areas. Japan, for example, has frequent earthquakes, and the Seikan tunnel had to be designed to survive massive tremors. Engineers use shock-absorbing materials and flexible joints to prevent tunnel collapse. Finally, worker safety is a big concern, specifically hyperbaric chambers. One of the biggest risks for workers building underwater tunnels is decompression sickness, also known as the bends. When workers are exposed to high-pressure environments for too long, their bodies absorb too much nitrogen, and if they return to normal pressure too quickly, it can be fatal. To prevent this, special hyperbaric chambers are used to help workers adjust to pressure changes slowly. Building underwater tunnels is extremely expensive, mainly due to the specialized equipment, safety measures, and materials required. Here are some of the most expensive underwater tunnels ever built. The Channel Tunnel connecting the UK and France cost $15 billion. Japan's Seikan Tunnel came in at $7 billion. The Hong Kong-Zhuhai-Macau Tunnel cost a staggering $20 billion. And the Fehmarn Belt Tunnel, which is currently under construction between Denmark and Germany, is estimated to cost $8 billion. But why spend so much money on tunnels? The reason is simple. These tunnels save time, improve trade, and provide safe travel. Unlike ferries, which are affected by bad weather, tunnels allow fast, reliable transport under the sea. We have already built tunnels beneath some of the deepest oceans, but what's next? Engineers are working on even more ambitious projects. For example, the Bohai Strait Tunnel in China. This tunnel will connect two major cities in China, and will be the longest underwater tunnel in the world when completed. There's also Elon Musk's Hyperloop project. There are discussions of building vacuum-sealed underwater tunnels where trains could travel at extreme speeds with zero air resistance. And who knows, maybe underwater cities? Some scientists believe that in the future we might build entire cities beneath the ocean, connected by tunnels instead of roads. The story of underwater tunnels is one of human ambition, innovation, and resilience. What was once considered impossible is now a reality. And as technology continues to evolve, who knows what the future holds? Maybe one day we will drive through tunnels that stretch across entire oceans, connecting continents like never before. Until then, every underwater tunnel we build is another monument to human determination, proving that no challenge is too great when vision, technology, and hard work come together.